Turn one of the lights off. See which one is the best one to turn off. All right, so this is the last part of R7. Hopefully we'll get through this today. Thank you. Oh, yeah. Looks like your book bag. All right, so we are going to do something called the least, and we've actually done this before this year. Least common multiple. Do you remember that? But we're going to do it with a little more complicated stuff this time. All right, it's not going to be quite as easy. But I am going to do a little throwback here. Throwback Friday. Isn't that what they call it? I know. All right, so here we go. We've got 12 and 15. If I want to find the least common multiple, for instance, if I wanted to, I don't know, like 5 twelfths plus 7 fifteenths. If I wanted to add those fractions together, what do I have to find? I got to find a common denominator. How would I find a common denominator? I could just multiply those two numbers together, but then that's going to be even tougher because I'm going to get some big old number. It's just going to make it a lot more difficult. So I'm not just going to multiply these two numbers together. What I'm going to find is I'm going to find the smallest denominator. Remember you did that back in elementary school when you did fractions? So that's called the least common multiple. The smallest number that 12 divides into and 15 also divides into. Does that make sense of what we're trying to do here? So I want to find the smallest number that 12 goes into and 15 goes into. Well, you might just be able to do it in your head. I don't know. You might be able to think of it. But if you can't think of it, if you can't do it in your head, this is what we're going to do. And this is going to be good practice for what we're going to do here in a minute. All right? So we're just going back in time to this easy stuff. So first thing I do on these problems is I factor them. All right? I want to find the prime factors. So I break this down into its prime factors. So what times what is 12? Well, there's several things, but 4 times 3 is 12, right? Break down 4, what do you get? Oops, almost wrote a 4. Yeah, you get 2 times 2. And then bring that straight down and you get a 3. So those are your prime factors of 12. Let's do the same thing with 15. It's even a little easier. What's that? Yeah, 5 and 3, or I'm going to write 3 and 5. I'm just going to put it down here so it's on the same level as this. Let's pop this up a little bit. Okay. So that's pretty easy so far. Now here's what I really want you to learn, because this is what we're going to do in the lesson today, but we're going to do it with more complicated stuff. We're doing it with rational expressions. Remember that? We've done that the last couple days. So what we're going to do, and again, I've taught this before. If you go back, I forget what lesson it was, but I did teach this before. But what I'm going to do is I'm going to figure out what numbers show up. So I'm going to put this in a box, and I'm going to put these in a box right here. Okay? So I've got these two sections, these two boxes. What shows up in any of the boxes? What numbers show up? Well, I got a 2. I got a couple 2s, right? I got a 3 here, I got a 3 here, and I got a 5. Everybody with me on that? Pretty easy, right? Let's see which ones show up. Now, we're going to choose particular ones. We're going to choose every number that shows up, but if it shows up more than once, we're going to pick the one that shows up like the most number of times, okay? So let's do the 2s. I have 2 2s over here, and I don't have any 2s over here. So how many times did the 2s show up? Twice, right? I got 2 of them. So what am I going to do? I'm going to write 2 times 2. You with me so far? What other numbers show up? The 3. But I got a 3 here and I got a 3 here. Now, it does show up twice, but it only shows up once in each of those boxes, correct? All right, did you hear what I just said? It does show up twice, but it only shows up once in this box and once in this box. So if it does that, if it shows up the same number of times in one spot as it does the other, we just pick one of them. So I don't pick both of them, I just pick one of them because it only shows up once here, it's only going to show up once there. With me? What other numbers show up here? A 5. Well, there's no 5s here, but that's okay. It still shows up here. How many times does it show up? Just once. So what do? We just put that down. Once we multiply all that stuff together, that's our least common multiple. That's the smallest number, when I multiply it together, that 12 and 15 both divide into. So what do we get? This is 4 times 3 is 12. 12 times 5 is what? 60. So 60 is my least common multiple. Or sometimes we just write it like that, LCM. That's our least common multiple. You with me on that? That was review stuff. Okay, that was, what did I just say? Throwback stuff. Back in the day, you learned that. So what we're going to do is we're going to take that same process and we're going to apply it to a little bit more complicated stuff, okay, with x's and x plus numbers and squareds and all that kind of stuff, all right? So it's going to be the same process, but it's going to be just a little bit more complicated. So I'm not even going to add fractions just yet. I want to find the least common multiple. Can somebody get that? Well, he can still open it. Thank you. All right, let's find the least common multiple of this crazy stuff. Now, this is not just a 12 and a 15. It's a little bit weirder looking, but really it's no harder to do. All right, that's one thing. That's kind of like my 12, all right, that I just did. And here's another. I'm going to put an and in there so you can see that they're separated. I'm going to put a 4 and an x minus 1 and an x plus 1 cubed. X plus 1 cubed. All right, so I want to find the least common multiple. So pretend this is a fraction, and this is one denominator of your fraction, and this is another denominator of your fraction. And you want to find the common denominator. This is what you want to do. You don't want to just multiply those two things together. Okay, that would be a pain. So what I want to do is find the least common multiple. So think of it as the boxes. Remember, I put the 12 in a box. Well, I didn't put the 12s, but I put the factors in a box, and I put the factors in the box for the 15. So I'm going to do the same thing with this. Now, what we have to do is we got to compare the two boxes and find out what shows up in each of them. All right, because you got three things. They're factors. They're things that are being multiplied. You have an x, you got an x minus 1 squared. What does that mean? How many x minus 1s do you have? 2 of them, right? Because it's squared. So think of it as x minus 1 times x minus 1. You with me on that? All right, and then you got an x plus 1. Over here, what do you have in this box? You got a 4, you got an x minus 1, and then you got how many x plus 1s? You got 3 of them, okay? Make sense? So what we want to do is just what we went through on that 12 and 15. We want to find out what numbers show up, and if they show up more than once, okay, we're going to take the ones that show up the most number of times. If it shows up in one place and it shows up in another place, we're just going to take one of those. Okay, so let's do it. Let's start with the x. I got one x here. Do I have any other just x's by themselves? No. So I pull out the x. Okay. What about this? I got an x minus 1 squared. Do I have an x minus 1 anywhere else? Yeah, right here. But I got 1 here. I got 2 of them over here. So which one am I going to pick out? Which one am I going to pull out? The one that shows up the most number of times. So which one am I going to pull out? The x minus 1 squared, right? Okay, so I pull out the x minus 1 squared. Do you see how it's very similar to what we just did with that 12 and 15? Okay. What else shows up? An x plus 1. Well, I got one x plus 1 here, but look over here. I got an x plus 1 what? Cubed. So I got 3 of them here, and I got 1 of them here. Which one am I going to pull out? The cubed. Okay, the one that shows up the most number of times. Does that make sense? So if it shows up in both places, I take the one that shows up the most number of times. And so I got an x plus 1 cubed. What other number shows up that I haven't picked out yet? The 4. Okay, it only shows up once, right? Once here, none here. It doesn't have to be in both places. It just has to show up in either one. All right, so I've got a 4. I got to pull that out. Where do you think I would put the 4? Do I think I put the 4 over here? No, I'd put it out front, wouldn't I? Yeah. So what did we just find? We found the what? Least common multiple. That's right. And what good is finding the least common multiple? It's kind of like a common denominator, isn't it? So again, if these were fractions and this was my denominator and this was a denominator, how would I find my common denominator? This is what I would do to find my common denominator. And that's the smallest thing that this divides into and this divides into. We good? All right. Now we're actually going to do a fraction with kind of weird stuff in the denominator. And we're going to have to find the common denominator or the least common multiple that we just finished doing. Okay? So that was just warm up. Now this is what you're really going to see. I really doubt, even on a test, or we're not going to have a quiz on this. This will be on a test. I really doubt that I'll put find the least common multiple. all right, I'll just give you a fraction, and you have to find the least common multiple in the fraction to find the common denominator. Everybody with me on that? So that was just practice to do what we're going to do right now. So here is an example. This, in the book, it's example 8. And there's no A or B. It's only one thing. And we're going to add these things together. All right, so let's write this down. If you have your book open, you could just look at your book, but I'm going to write it down as well. All right, so there's one fraction. Now this time we're adding fractions together. As soon as you see that you're going to add fractions together, you have to find a common denominator. All right. There's an extra step to this too that we didn't really talk about, but we've done this before. Okay, do you see how it all builds on itself? Okay, we learn the stuff at the beginning, then you're going to use that stuff from the beginning to do over and over again. So we're going to have to do something here before we find a common denominator. Look at this denominator. What do you think we need to do first with this denominator right here? Because this is not written as as factors. It's not something times something, is it? All right. Well, you think, yeah, it is. It's x times x, or it's 3 times x. But it's not like one parentheses times another parentheses. So what do we have to do with this thing right here? Somebody give me a good word. Say it. Factor. That's right. We got to factor this. All right. So let's do that. You're like, well, Mr. Hamrick, I thought this was just adding fractions. Why are we factoring? Well, because we got to do the stuff that we learned earlier. All right. And we got to get factors down here to find that least common multiple. We did that with 12 and 15, right? We broke it down into its factors. And that other problem that you had to find that least common multiple, they were factors. So we got to factor this. This is an easy one. This is like the easiest trinomial factoring that you're going to do. What is it? Plus what? 2 and 1. That's right. Plus 2 plus 1. Well, this next one may rival this as the easiest factoring you're going to do. Let's just keep the 2x minus 3 up here. This is a difference of 2 squares. That's probably just as easy or even easier. So what's this going to be? X plus 1, x minus 1. I'm not going to go through why we got it because we've already had lessons on that. Okay, we've had a quiz on it. So now what we're going to do is we're going to find a common denominator. All right, so let's off to the side. A common denominator is the same thing as finding the least common multiple. So off to the side, let's just figure, you know what? We don't have to go off to the side. Let's just put this over one denominator. So let's see. This is kind of like in our box right here, and this one's in our box right here. I'm just not going to draw the box. It's just too messy. So let's see what shows up. Well, we got an x plus 2 down here. Are there any other x plus 2s? Nope. So we just pull out one of them. So we have an x plus 2. What other thing shows up? What other factor shows up? An x plus 1. Let's see if there's any other x plus 1s. Yep, one right here, but it's on the other side, right? It's the other fraction. So I got one here and I got one here. Do I pull out both of them? No. If it shows up the same number of times, right, you just pick the one, you just pick one of those. So this only shows up once, this shows up once, we only pick one of them. X plus 1. All right, what other thing shows up here? The x minus 1. The x minus 1's here, there's no other x minus 1, so we just take out one of them. That's our common denominator. With me on that? If you wanted, you probably don't really have to separate them like this. I'm going to just to, for some of you, it may make it a little bit easier. Some of you guys could go right to the one fraction and figure out what your numerator is going to be. But I'm going to separate them both. All right, now it's time for another color. You guys said you could see yellow yesterday, so we'll use that. So here's the question. What did you do to this in order to get to this denominator right here? What do you think, Mac? That's right. We took this stuff. What's the only thing not here? An x minus 1, right? So we had to multiply this by an x minus 1 in order to get this. So if we did that to the bottom of this one, talk to me. We got to do it the same thing to the top. Remember yesterday? Because really, I'm multiplying the top and the bottom by an x minus 1. What is that? What's x minus 1 over x minus 1? It's just a 1. Am I allowed to multiply something by a 1 and not change the value of it? Yeah, absolutely. So I'm just going to do that. Now, I could have put x minus 1 down here on the bottom. I'm just going to save myself a little writing. So I know I had to multiply the bottom by an x minus 1, so I got to multiply the top by an x minus 1. We'll write this in just a second. All right, let's do the same thing to the other one. What did we do to this? Right there, to get to this thing right there. X plus 2, right. So we multiply this by x plus 2 to get to this. So what are we going to do to the top? Multiply this by what? X plus 2. It's just like doing a regular fraction with regular numbers, right? It's the same principle. It's the same idea. It's just a little bit more complicated because you got a lot more junk to write down. All right? So let's figure out what this is going to be now. Let's go ahead and actually do the distributive property here and then stick it right here. All right? So when we multiply those together, what do we get? Oops, I thought I was back to white. There we go. So what do we do when we multiply those together? We get what? X squared minus x. So now we got the numerator for the first fraction because I just multiplied those together. The reason I'm multiplying them together is because when I add these two fractions together, most likely I'm probably going to have some like terms I need to add up. All right, so I want to make sure I multiply those together. The bottom, though, we talked about this yesterday, the bottom can stay in factored form. In fact, the book says keep the denominator in factored form. Okay? I didn't write that up here, but that's what it says to do. We talked about that yesterday. Now, let's do the same thing over here. Let's multiply this together and stick that right here. Now, this is a FOIL method, a little more difficult than this, but at this point, we should be able to do simple FOIL methods, right? Easy, small numbers. We should be able to do those in our head. So well, I tell you what, I lied. Let's just do the whole thing, because this is a 2x. Let's just do the first outside, inside last, okay? So the first, 2x times x, 2x squared. The outside, 2x times 2, plus 4x. The inside, negative 3 times x, minus 3x. And the last, negative 3 times 2 is negative 6. Extend that little fraction bar. All right? We're almost finished. In fact, this next step is our last step. So I can so now I have a common denominator. These denominators are exactly the same, so now I can write it with one common denominator. It seems a little long, process, but we've done every one of these things before, okay, separately. Now you're just kind of putting a few things that we've learned before together into one problem. That's what math's all about, right? You learn it in increments, little bit, little bit, little bit, and then bam, you put them all together. All right, that's what we're doing today. Now, let's do some like term stuff here. We can do that. This is a plus sign, so it makes it pretty easy. You don't have to distribute a negative. If this was a negative, you'd have to put this in parentheses and make sure that you distribute that negative through everything. It's a plus, so we don't have to worry about changing the sign, so we're good. So let's add some like terms. Well, I got a 1x squared here. Do I have any other x squareds? Sure, right here. So 1x squared plus 2x squared gives me 3x squared. If you want, bam, bam, get rid of them. All right, just so we know we're done with it. We don't get confused. Let's do x's next. So I've got a negative x plus 4x minus 3x. Let's do this plus 4x minus 3x. What's that? 4x minus 3x is what? X. So negative x plus x is 0. Do I need to even write down the 0? No, I don't. Okay? So I don't have to worry about that. So I'm done with the x's. What else is left? Just a negative 6. Okay? I could probably let you leave the answer like this, but the book doesn't, and I know why they don't. Because you can factor the top, can't you? And you have to be careful. Josh, you asked me about this, I think, yesterday. Are there going to be problems where you can factor the top and then cancel out with the bottom? It's a possibility. Okay, I don't know for sure, okay, on these problems. Again, like I said yesterday, I haven't done every one of these problems, but just to be careful, I would factor this out. Okay, and then see what's left, if anything can cancel with the bottom. All right, it may not, or it might. So you just got to try it. So if I factor out a 3 from this, I got an x squared minus 2, and then the bottom is x plus 2, x plus 1, and then x minus 1. Does this x squared minus 2 cancel with anything down here? No, it doesn't. Can you factor x squared minus 2? It almost looks like a difference of 2 squares, doesn't it? But it's not, because you can't square something to get 2. So it's not a difference of 2 squares. This won't factor anymore. So this would have been perfectly fine to leave your answer, or put a or this. I believe the book will probably give you this right here as your answer, okay? But I would accept this, because if you did factor it, nothing cancels out anyway. So if nothing cancels out, it's not that big of a deal. But you just got to be careful that you got to make sure that nothing else cancels out, because there's a possibility that it could happen. Now, that was a few steps, right? But really, it wasn't much different than just a regular, plain old fraction with regular numbers. I don't know, I think. Due to time, I'm going to skip example 9, okay? The only thing different with example 9, and I kind of touched on it on this example right here, is this. Example 9 is basically the same kind of problem, except instead of a plus, what do you think they have there? A minus, okay? And what did I say you got to be careful with? If this is a minus, okay, yeah, you got to take this. Pretend this was minus, you'd have to distribute it. And so this step right here would be what? Negative 2x plus 3. Make sense? That's basically the only difference on that next example. And just for the sake of time, I want to get to the next one, because the next one's a little bit different. It's kind of the same, but different. Example 10. Thank you. All right, this says to simplify. And here we go. This one's going to really look crazy. But again, everything that we're doing in this problem, we've done before. We just haven't done it all together. All right, so there's really nothing new to this. It's just taking a few things we've learned in the past, putting it all together, and getting an answer. Plus 3 over x. Now that right there doesn't look so bad, does it? But look what they're going to do. They're going to put a big old fraction thing. That's what you're going to simplify. You're like, yeah, you're crazy, Mr. Hamrick. How am I supposed to do that? Well, really, what do you see right away? You see fractions, obviously. But you see that big old fraction bar, don't you? You see fractions on top of other fractions. So what was our little catchphrase? What was our little thing? Keep, right? Cancel, and what? Flip. All right? Keep, cancel, and flip. So we keep this the same. Did I say cancel? Why did I say cancel? Change. I don't know. We talked about canceling a lot the last couple days. So that's where I would say it's keep, change, and flip. Sorry. So it's keep this the same, change this sign, and flip this. Let's do that right now. You okay with that? I'm not even going to simplify this fraction. I'm not going to add that fraction just yet. I will eventually, but not right now. So let's keep that the same. So that's 1/2 plus 3 over x. I'm going to change this sign to a multiplication. And then I'm going to flip this. So it's 4 over x plus 3. I actually, when I did this problem myself, okay, I actually simplified the fraction first. Then I kept it, changed it, flipped it. Okay, so it doesn't matter. I don't know. Just when I saw it, I thought it might be a little easier for you just to do that keep, change, flip thing right away. All right. So what do I have to do before I do any multiplication? Can I go 3 over x times 4 over x plus 3? No. Okay, even though this is our numerator, see, we got to do that stuff first, and then we can multiply by this stuff right here. All right, make sure that you understand that. That could be a little confusing because that 3 over x is being multiplied, and we always do multiplication before we do addition and subtraction, but it's this whole numerator times this whole denominator. So what are we going to have to do with this thing right here? Add those fractions together, right? This is actually a pretty easy one. What's our common denominator? Just 2x, okay? If you want, we can just put it over 2x instead of separating them, couldn't you? So what'd you do to the 2 to get to 2x? You multiplied by x. So you multiply the top by x. So what do we get? 1x or just x? plus, what do we do to this x to get to 2x? Multiplied it by 2. So you do the same thing to the top. So 3 times 2 is 6. You with me? Times this thing right here. I can't simplify that. X plus 3. There we go. So what could we do here? Let's just multiply it. All right. I'm not going to distribute. I'll show you why in a second because I see something. I'm going to go 4 times x plus 6. So I'm just going to put a 4 and an x plus 6. Or you could do this. I'll tell you what. Let's not do that just yet. I could have done it in the next step. But do you see anything else that cancels? X plus 6 and x plus 3? They can't cancel. They're not the exact same thing. They got to be exactly the same thing, or they got to be able to divide into each other. What do you see? It's real simple. It's not a hard thing. It's a real easy thing. The 2 and the 4. It's not the x. The x won't go into 4. Okay, but the 2 will. Okay, 2 divides into 2 how many times? Once. 2 goes into 4, what? Twice. You with me on that? Okay, let's turn this up a little bit. So now what you can do is you can go 2 times what? X plus 6 over, what's the bottom? It's just x times x plus 3. Does anything cancel here? Nothing cancels, does it? All right, I can't cancel anything out. Does this x right here cancel with this x down here? No, because this x is being added. Remember, if it's being added, you can't cancel out. That's it. That's your answer right there. Simple as that. Again, you could approach this a couple different ways. You could have gone 4. This is how I did it when I did the problem myself. 2x, x plus 3. All right, so I did this, and then I canceled. But really, does it make any difference? No, it doesn't make any difference if we do it here or if we do it here. All right, you still get the same exact thing. All right, let's do one more. Then we'll be finished with this lesson and this whole section. I never remember what time we get out of places. Oh, my goodness. I got 3 minutes. Are you kidding me? Well, there's no way I'm going to be able to finish that in 3 minutes. So what we're going to do is we're going to stop here. But I'll tell you what. Since you guys showed up today and it's first period, I'm going to give you a hint. Okay? And if anybody's watching this video, which they should if they're not here, okay, that goes for everybody. If you're not here, watch the video because you never know what I might say on the video that I don't say to everybody in class. So I'm going to attempt, okay, I'm not going to promise you, but I'm going to attempt to make a video this weekend that you're going to want to see. Do you hear me? I'm going to do it on my own at the house, okay, and you're going to want to watch it. That's all I'm going to say. All right? You got it? Okay, it's not a hiking video. It's math, okay? But you'll want to see it. So it should be up by the end of the weekend, definitely on Monday. All right? Watch it on Monday because remember, we're having a test on what day? No, Wednesday. We're having it on Wednesday. We're doing corrections on Thursday. Be here Wednesday. It's not first period on Wednesday, so there's no reason to be late. There's no reason to be absent. Okay, be here. And hopefully I'll have it up. I don't know. I might even do it tonight. Who knows? We are. We're going to collect the homework before you leave. And then Monday, we'll do review. We'll go over that homework. We'll go over this homework. By the way, before I stop recording, I got to give you some problems to do, don't I?
It's Friday.
Is that right?
Yeah.
Okay, thanks for letting me know. So it's part 3, and it's pages. Remember, I don't do this as a punishment. Remember that little talk I gave you yesterday? It's not a punishment. This is to help you. So you're welcome. There it is right there. Okay, let me stop recording, and then you guys can turn your homework in, and then you can go.